Moving right along to problems 15 through 19 here. Again, we have another problem here asking us for the most reactive, and in this case all of the compounds shown here are amides. One of them, however, this one right here, is a beta-lactam ring, and the beta-lactam ring is one of the most unstable of the amides because it's in a four-membered ring. So that's the one on that. Here, problem number 16, you can read through that. Here it's basically saying, here we have an amide. How does that compare to the stability of this ketone right here? And the answer to everything is resonance. So here, it's a little bit more complicated the way it's worded in this one. The lone pair right here is in a p orbital, and that makes it delocalized. Delocalized is another word for resonance. So that's the answer right there. Nitrogen in propane amide here has a lone pair in the p orbital that delocalizes with the p orbital of the carbonyl carbon. And that is correct. Okay, number 17. This is a naming problem that also has a bit of synthesis to it. So to know what you're going to name here, you got to know what the product is. Let's figure this out. After step 1, chromium here, CrO3 here, oxide. That chromium, since it has so much oxygens, will usually carry out an oxidation. So if we have chromium and that's added to a primary, primary means that this carbon is only attached to one other carbon over here. If it's attached to a primary, then it's going to become a carboxylic acid. Only PCC will create the aldehyde here in this case, or other specialty reagents, but that's the important one to remember. And since we have a carboxylic acid here, if we carry out this reaction with the ethanol right here, that ethanol is going to add right here. So this is still a substitution reaction. It requires an acid to make this a good leaving group. Right here, currently the leaving group is negative, and we want to make H2O from this here, which is a good leaving group. This is bad. Oh my goodness, can't even write bad. Bad. This is good. Okay, and then that's going to make this. So embarrassed now, can't even spell. Worst speller in the world. Not going to worry about that, just ignore what I said. And let's see, what is this compound? Ethyl 2-methylpropionate. Notice here, a lot of times I give you really very easy ones here. This one is ester, this one's a ketone, this one's an amide. This one, using that little suffix right there plus the word chloride right there, indicates an acid chloride. So we only got one ester here in this whole bunch. Okay, another highest to lowest reactivity. There was a lot on the group study, probably not going to be as much tomorrow on the exam. But let's see here. These are just usually very basic. You have to look carefully at what's being asked. Lowest to highest reactivity. So here, the highest reactivity would be the most unstable. See if I can spell this correctly. Yep, there we go. Most unstable is acid chloride. Next is this, what is this? Anhydride right here. Then we have an ester. And notice I'm not even looking at the answers. You just have to rank these on your own and then look at the answers. Then we have the amide, which is the lowest reactivity because it is the most stable in that case. So this is the most, you could say least stable or most unstable, however you want to phrase that. And let's see, where's the answer choice here? We got 1, 3, No, not that one. 1, 3, 4, 2. B is the answer on that. Okay, and 19 here, the last one is asking for a gamma lactone. Lactone means a cyclic ester, and it's not as easy to remember as lactam, but the "one" here should remind you there's an oxygen right in there. It kind of sounds like ketone, but it's not a ketone, unfortunately. It is a cyclic ester. It's a little bit tricky once you get going on the MCAT or PCAT or whatever you're going to take. All right, that's problems 15 through 19.